In Chapter 18, we're going to learn about derivatives of carboxylic acids. So let's take a look at what we're going to be learning in this particular chapter. Here we're going to focus on acyl compounds. And an acyl compound is nothing new. We've actually seen a lot of acyl compounds when discussing carboxylic acids. And they are defined as carboxylic acid derivatives. So sometimes you'll see acyl compound carboxylic acid derivative kind of interchangeably. They have a formula where you have an R group connected to an acyl group with an Lg, where Lg stands for a leaving group, that's attached to the acyl group. So the acyl compounds that we're going to be focusing on, or the derivatives that we're going to be focusing on, are acid chlorides, where you have the leaving group being chloride, esters, where the leaving group is an OR, so an alkoxide. We can even think of carboxylic acids as acyl derivatives, where a leaving group would be an OH. And then we have amides, where the leaving group is an amine. And lastly, we're going to be looking at acid anhydrides, where the leaving group is a carboxylate. So all in all, these are referred to as acyl compounds, where you can see they all have the general formula of that R with an acyl group attached to some leaving group. Now, the other thing that we'll take a look at throughout this chapter are nitriles and a structure that looks like this, which you may be familiar with. This is called a ketene. And nitriles and ketenes are actually acyl-like compounds. We'll see that they undergo similar reactions as those of the acyl compounds. Now, the chemistry of acyl compounds we say is intertwined. And the reason for this is because a reaction of one type of acyl compound generally leads to the production of another. And we can think about the kind of a generic reaction scheme where we have our acyl compound that reacts with a nucleophile. And what happens, typically speaking, is the nucleophile attacks the carbonyl carbon, where we have seen already that carbon is an electrophile, and undergoes an addition reaction. This leads to an intermediate species that looks like this, where now you have the nucleophile that's creating a sigma bond to that carbon. And this is called a tetrahedral intermediate. And then that tetrahedral intermediate, when that carbon has a good enough leaving group on it, it can actually then undergo an elimination reaction, eliminating that leaving group and reforming the carbon-oxygen double bond. And so the product is now a new acyl compound. Obviously, the leaving group has now come off of it. So as you can imagine, these are called addition-elimination reactions. And this is certainly nothing new. We've seen addition-elimination reactions before, but in this chapter, that's basically going to be the main focus, the main type of reaction that we're going to be looking at.